If we have a polar curve r equals to r theta, and we want to find the area bounded by that curve between angles theta equals to alpha and theta equals to beta, we partition the angle into smaller sub-angles. So we divide the angle between theta equals alpha into theta equals beta into smaller sub-angles. So theta equals to 0, theta equals to 1, theta n, which is beta. So we divide it into n smaller sub-angles. And length of each of the measure of each sub-angle is going to be delta theta. Delta theta is going to be beta minus alpha divided by n. Now, if we want to find the area of the whole thing, we approximate it by approximating the area of small sub region. So we'll look at, let's say, AI here, this piece. Now let me concentrate on this piece. So if I try to approximate AI, it's between theta I minus 1, theta I. What I do is I pick a point, or pick an angle between theta I minus 1 and theta I, say theta star I. And then I approximate a area of that ith piece by saying it's approximately equal to the area of circular sector. And area of circular sector equals to radius. And radius is going to be r theta star I radius squared multiplied by angle, which is going to be delta theta divided by 2. So that is our approximation to a ith piece. So recall that the area of the circular sector equals r squared times measure of angle divided by 2. So what we got now is total area is going to be equal to sum of partitions, and we approximate each small partition into the thing which we just did. To get better approximation, we take n to be approaching infinity, or delta theta approaching 0. So we take limit as n approaching infinity of our approximation. And at the limit stage, we're going to get the area we are looking for. And recall what we've got is we've got limit of Riemann sum. Limit of Riemann sum is definite integral. Definite integral is going to be from initial angle to the last one, so from theta equals to alpha to theta equals to beta. Function becomes r squared theta over 2 d theta. So we derive the formula for the area in the polar. Area of function given in polar coordinates. It's going to be integral alpha to beta r squared theta over 2 e theta. So that's the picture we're referring to. Angle theta equals to alpha, angle theta equals to beta, our curve. And if we want to calculate this area, we calculate it by formula area equals to integral from alpha to beta r squared over 2 d theta. If we have polar curve r equals to r theta, we have angles theta equals to alpha and theta equals to beta, and we want to find the area bounded by that polar curve on that angular sector between theta equals theta alpha and theta equals to beta, and we know we just derived that area equals to 1/2 integral theta equals to alpha theta equals to beta r squared d theta. Let's use this formula to calculate an example or two. So in this example, let's look at the limmason. R equals to 4 plus 2 cosine theta. Find the area. Closed by this limmason. Firstly, let's look at the picture. So picture looks something like this: 6, 4, 2, 4. So limmason. And we're looking for that area. So to find this area, we start with angle equals to 0. And we start going around till we go back to theta equals to 2 pi. So area, our initial angle going to be theta equals to 0, and we go around till we're going back to our initial angle theta equals to 2 pi. So we found the limits of integration alpha and beta, put 1/2, square of expression for radius, theta. Now we'll do a little bit of algebra to evaluate this integral. FOIL or use square of sum formula. So 16 plus 16 cosine theta plus 4 cosine squared theta d theta. So we're going to get 1/2 integral 0 to 2 pi. Antiderivative of 16 is 16. So we're going to get 1/2. Antiderivative of 16 is 16 theta. Antiderivative of cosine is sine. Antiderivative of cosine squared. I might use cosine reduction formula. So with n equals to 2, so I'm going to get cosine theta sine theta over 2 plus theta over 2. And we do it from 0 to 2 pi. So we're going to get 1/2 16. So substituting 2 pi, we get 16 times 2 pi plus sine of 2 pi is 0. Sine of 2 pi is 0. 2 pi over 2 is pi. So we're going to get 1/2. 16 times 2 is 32 pi plus 4 pi. So we're going to get 36 pi over 2. Final answer is 18 pi for